This video is about the quadratic formula. And the most common thing on ACT that you will run into for having to use a quadratic formula is they will ask you what format zeros are in. And zeros of what? Of a quadratic. Remember, a quadratic is something that's a parabola. It either looks like that where it touches, let's pretend that touches at one point because I'm not a good artist. It might touch the x-axis at 2 points. It might touch the x-axis at no points. It might be upside down and do any one of those three things. Let's pretend that touches at 1 point, or again touches at 2 points, or again touches at none point. It could be either one, any of those. And how do we know which one it is? Well, these equations, we say it's f of x. Sometimes we say it's y equals ax squared plus bx plus c. And that's called a quadratic. It's something squared, and then there's an x to the first power, and then there's a constant term. And if this a is negative, that means it's upside down. If it's positive, it means it's right side up. But the quadratic formula tells us what the zeros are. Sometimes they're called the solutions. Sometimes they're called the x-intercepts. Where does this quadratic or parabola touch the x-axis? It's either going to be one place, 2 places, or no places. And we'll get to that in a second. But the quadratic formula tells us where it touches. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And a is whatever number is in front of x squared. If there's no number in front of x squared, a is just 1. B is whatever's in front of x, and c is the constant. Now this part inside the square root is what's called the discriminant. It lets us discriminate or tell the difference between the different kinds of solutions. In other words, it lets us know if it looks like this, or if it looks like this where it touches in 2 places, or it looks like this where it touches in no places. So the discriminant. If the discriminant, b squared minus 4ac, is greater than, hold on, we don't want to do greater first. If it's equal to 0, it means we have one real solution, and it's always repeated twice. There's always 2 solutions. So if it's equal to 0, that discriminant, there's only one real solution, but we say it's repeated twice, and it's said to be rational. What does rational mean? Rational is a number that can be expressed as a over b, where a and b are both integers. So things like 3/4, that's a rational number. Things like 1 is a rational number because we could write any whole number or integer, we can write it as 1 over 1, as over 1. 1/3 is a rational number. It's one integer 1 divided by another integer 3. If it's a decimal, it will either be a terminating decimal, it ends like 0.25, which equals 1/4, that's a rational number, or it's a repeating decimal like 0.333, which is 1/3. But so if the decimal repeats and goes on forever, or if it ends, it's a rational number. Another one would be like 2/3, which is 0.6666, repeating forever. And it doesn't always have to be one number. Sometimes a repeating decimal could be like 0.325, 325, 325. Irrational numbers are numbers like pi. We can express pi as 22/7, but that's only an approximation. There's no fraction of integers that's an exact value of pi. Square root of 2 is irrational. You can't access it. You can estimate it, but you cannot express it as one integer over another exact value. So if the discriminant equals 0, then we know there's one real solution, it's repeated twice, and it's always rational. It'd be like this, or like this, where it only touches the x-axis. I know this one kind of doesn't, but we're pretending. We're in the world of make-believe, and we're pretending. All right, what if it's greater than 0? If it's greater than 0, there's 2 real solutions. And we can get even more information, because if it's greater than 0 and it's a perfect square is a number that if you take the square root of it, you get an integer. So like 4 is a perfect square, because the square root of 4 is 2. 25 is a perfect square. The square root of 25 is 5. 3 isn't a perfect square, because the square root of 3 is not an integer. It's some kind of a decimal number. So if it's greater than 0, it's two real solutions. If it's a perfect square, both of those are rational. And we've run into the end of the page again. I always run into the end of the page. It's supposed to be an I there, I-O-N-A-L. Okay, I can spell. And if it's not a perfect square, so in other words, let's say it's the square root of 3 or the square root of 5. There is no integer that's the square root of 5. If it's not a perfect square, it's irrational. And we'll get an example of this in a moment. And then if it's less than 0, it has two complex solutions with non-zero imaginary component. So that's what it tells us. All right, so greater than 0 is two reals. It's like this situation where it touches the x-axis twice, or this situation where it touches the x-axis twice. And then less than 0 is like here, when it doesn't touch the x-axis or axis, or here when it doesn't touch the x-axis. All right, let's look at an example of this, and we will use the discriminant to determine what the solutions look like. You can also use the quadratic formula to find the zeros or solutions for any quadratic. There's another method to find it for simple ones, but you can also use a quadratic formula. All right, I have examples here, and let's see, quadratic formula A09, number 28. So let's close that and go here. A09er. There it is. And then we want question 28. 28. So notice it says, which of the following most precisely describes the roots of the equation 5x squared plus 7x plus 2 equals 0? Now, we can eliminate one answer choice immediately, because remember, if it equals 0, it has one real solution, repeat it twice, times 2, and it's always rational. This one says one rational double, means repeat it twice, root, and one irrational double root. There's no way to get one irrational double root. It's always going to be a rational double root. So G you can instantly eliminate. And I know I've already circled the answer here, but we're going to show you how to find it right now. So it would have to be a rational double root if it equaled to 0. But let's find out what the discriminant equals on this one. And boy, hold on, let me make this smaller and add some extra space, because I think I want to do one more example. So I'll go like that. How do you like that? And then we'll zoom in again. So I can do this example here as soon as I find my zoomer. Boom. And then I'll do another example a little bit later. So this is 5x squared plus 7x plus 2. And let me choose the pen. 5x squared plus 7x plus 2 equals 0. You may remember what that was. I don't, so I have to look back. 5x squared plus 7x plus 2 equals 0. All right, so remember, what's in front of the x squared is a, what's in front of the x is b, and then the constant is c. And all you have to worry about to determine which kind of solutions it is the discriminant, b squared minus 4ac. So this is going to be 7 squared minus 4 times 5 times 2. 7 squared is 49. You could always do this on your calculator. 4 times 10 is 40. 49 minus 40 equals 9. So it's positive. It's greater than 0. So if it's greater than 0, there's two real solutions. And then look at what it is. It's 9. It's a perfect square. And if it's a perfect square, they are rational. That's where my I goes. I just blend it right into my O by mistake. All right, so greater than 0, it's a perfect square. So they're both rational solutions, and the answer is 2 rational roots. If it was 7, let's say, then they would be 2 irrational roots. If it would be -7, it would be 2 complex roots with non-zero imaginary parts or portions, whatever you want to say. All right, I'm going to do another example. Let's try 2x squared plus x plus 2 plus 3 equals 0. All right, remember, we're worried about the discriminant. B squared minus 4ac. Here's a. There's no number there, so b is just equal to 1. When there's no number, it just means 1. And then c is equal to 3. Okay, I'll put it down there. All right, so b squared, 1 squared, minus 4, times 2, which is a, times 3, which is c. 1 minus 24. That's a negative 23. Uh-oh, it's less than 0. Well, the answer to that one, if it's less than 0, let's look up here. Less than 0, 2 complex with non-zero imaginary components. So if 28 instead of the one they gave us was actually 2x squared plus x plus 3, then the answer for that would be K, 2 complex with non-zero imaginary parts. And you can look that up on YouTube again. Look at quadratic formula using the discriminant to determine the roots. And you'll see all kinds of other videos with examples of it. But there's a good example of it. And that's most commonly what the quadratic formula will be used for on the ACT. That is all.